Hello, space fans. You're tuned in to Astronomy Daily, your weekend home for the biggest stories from the cosmos. I'm Anna.
And I'm Avery, and what a week it has been.
We've got two fresh stories to kick things off, and then, as always on a Saturday, we're bringing you our weekend wrap, the four biggest space and astronomy stories from the past 7 days.
So let's not waste a second. Let's get into it.
So this first story is about something that has frustrated solar scientists for decades, and honestly, it's about time it got sorted.
Oh, I know what you're going to say, the far side.
The far side. Every 28 days, the sun rotates all the way around, which means anything happening on the side we can't see from Earth, sunspots, flares, eruptions, has historically been a mystery until it swings into view.
And by that point, you might only have days of warning before whatever's brewing rotates directly toward Earth.
Exactly. Now, scientists have had a technique called helioseismology for about 25 years, basically using sound waves reverberating inside the sun to locate where large active regions are forming on that hidden side.
So a bit like using sonar to look for things you can't directly see.
Great analogy. But here's the thing. That technique could tell you that something was there. What it could not tell you was the polarity of those active regions.
So polarity matters because
the polarity of a sunspot group, which way the magnetic field is pointing, is one of the most important factors in how powerful an eruption might be. Get the polarity wrong and your forecast is basically useless.
So what's changed?
A team led by solar physicist Amr Hamada at the National Solar Observatory have developed a new method using data from NOAA's Global Oscillation Network Group, GONG, a network of robotic telescopes stationed around the world that continuously records the sun's surface oscillations. They found a way to analyze phase shifts in the helioseismic maps and assign actual magnetic polarities to far-side sunspot regions.
So we're not just seeing where the sunspot is, we're now getting information about how dangerous it might be before it's even visible.
And to put a very real-world spin on this, just 2 days ago, on May 7th, a significant solar flare erupted from the sun's far side. The event was partially blocked by the solar horizon, so we don't even know how large it really was. The question already being asked is what's coming back around?
That's genuinely exciting and a little unnerving.
The team's results have been published in scientific reports, and the findings are being hailed as a breakthrough for full sun magnetic mapping. The more we can see the whole sun at once, the better we can protect the satellites, power grids, and astronauts that rely on space weather forecasting.
Massive step forward. Love it.
Okay, story 2 comes from the James Webb Space Telescope. And I have to be honest, I feel like almost every week, JWST is breaking something we thought we understood. At this point, it's basically its personality.
Right. So this week, a team led by researchers at the University of California, Davis has published findings in Nature Astronomy about a galaxy called XMM VID-ON 2075. And before you zone out at the name, here's why it matters. This galaxy formed less than 2 billion years after the Big Bang.
Which in cosmic terms is extremely young.
Extremely young. Now, according to everything we understand about how galaxies form, young galaxies should be spinning. Angular momentum from inflowing gas, the influence of gravity during formation, it all sets them rotating. Over billions of years, through mergers and other processes, some of them eventually slow down and become these large, settled, non-rotating systems.
But that takes a very long time.
A very long time. And yet, XMM VID 2075 shows essentially zero rotation. None. It has already settled into that mature, non-spinning state at an age when it should still be churning away like a cosmic washing machine.
So how is that even possible?
That's the big question. Some simulations do allow for a very small number of these objects in the early universe, but they're predicted to be incredibly rare. Finding one is already significant. The team is now actively searching for more to understand just how common or uncommon they might be.
And I understand this galaxy was already on the radar as one of the most massive in the early universe.
It was. Previous observations confirmed it already had several times as many stars as our entire Milky Way and had stopped forming new stars. both traits of a much older evolved system. JWST was then used to measure how material was actually moving inside it, and the result was it basically wasn't.
Shouldn't exist, but it does. That's JWST in a nutshell.
Every week, every single week.
All right, time for our weekend wrap. 4 stories, the biggest space and astronomy news from the past 7 days. Avery, set it up.
Let's do it. This week we have a cosmic odd couple that shouldn't be together. 250,000 citizen scientists who've quietly doubled the book of brown dwarfs, a NASA mission that's about to launch inside a space donut, and the Webb first that nobody has done before. Big week.
A space donut? We'll get to that. Let's start with wrap story number 1. A planetary pairing that MIT scientists are calling one of the rarest architectures astronomers have ever found. It involves a hot Jupiter and a Mini-Neptune, 190 light-years from Earth, orbiting the same star. And according to everything we know, one of them should not still be there.
Hot Jupiters are legendary bullies.
They really are. They're massive gas giants that orbit very close to their star, and their gravity is so intense that any planet daring to share the neighborhood normally gets flung away into deep space. Hot Jupiters are almost always found alone.
Except in this system, TOI 1130, where a Mini-Neptune is not only surviving, but orbiting even closer to the star than the hot Jupiter.
Which has been puzzling scientists since the system was first discovered in 2020. Now, a team at MIT has used James Webb to actually read the atmosphere of the Mini-Neptune for the first time. And what they found is a heavy mix: water vapor, carbon dioxide, sulfur dioxide, and hints of methane.
And that heavy atmospheric chemistry is the clue.
Exactly. If this planet had formed where it currently sits, close to its star, it would have a light atmosphere, dominated by hydrogen and helium. Instead, it's dense with molecules that point to formation in the cold, icy outer reaches of the protoplanetary disk, what astronomers call beyond the frost line.
Which suggests both planets formed far out and then migrated inward together, maintaining their atmospheres as they went.
This is actually the first measurement ever made of the atmosphere of a Mini-Neptune sitting inside a hot Jupiter's orbit. Genuinely unprecedented. Published this week in the astrophysical journal Letters.
2 planets that shouldn't coexist, and yet they do. In perfect, if bewildering, harmony.
Wrap story 2. And I love this one because it's a reminder that some of the most significant contributions to astronomy right now are being made by ordinary people sitting at home with a laptop.
NASA's Backyard World's Planet 9 project.
The very same. So for those who haven't heard of it, this is a citizen science program where volunteers sift through infrared data from NASA's retired WISE satellite, looking for objects that move. Stars move slightly against the background over time, brown dwarfs move, Planet 9, if it exists, would too.
And along the way, the volunteers have been finding brown dwarfs in remarkable numbers.
Remarkable doesn't cover it. A new paper published this week in the Astronomical Journal with 75 authors, 61 of whom are volunteers, announces that the project has discovered more than 3,000 brown dwarfs over its first 10 years, essentially doubling the known population.
For listeners unfamiliar with brown dwarfs, they're often called failed stars. Too massive to be a planet, not massive enough to ignite nuclear fusion like a true star. They're about the size of Jupiter. They glow faintly in infrared, and they're surprisingly common, about 1 for every 3 or 4 stars near our sun.
But because they're so dim, they've always been hard to find, until now.
The discoveries include objects never seen before, extreme T subdwarfs, ultra-cool objects, and apparently one brown dwarf that may even have aurorae on a brown dwarf.
1,000,000 times brighter than the northern lights on Earth, if you could see them. The project is still working through more than 2 billion sources in the WISE data, so there are almost certainly more finds to come.
Science powered by people. I'll never stop finding that inspiring.
Before we head into our next story, the donut I mentioned earlier, I'd like to take a moment to remind you about our sponsor, NordVPN. As I keep saying, when you're ready to secure your online life, get the best and help support the show while saving a heap of money. We use NordVPN and reckon you should too. To get our special no-risk deal, just click on the link in the show notes. Thank you.
Amen to that.
Okay, wrap story 3. And this one is timely because it's happening in 3 days. On Tuesday, May 12th, SpaceX launches the 34th cargo resupply mission to the International Space Station. And among the 6,500 pounds of cargo heading to orbit is something rather unusual.
Tell them about the Doughnut.
The Doughnut. So, surrounding our planet within Earth's magnetic field is a structure called the ring current. It's an invisible donut-shaped region where charged particles from space get trapped and flow in opposite directions. Positive particles one way, negative the other, creating actual electrical currents.
And this ring current matters because during solar storms, it can intensify dramatically.
When that happens, those electrical currents can induce magnetic fluctuations that ripple down to the ground, disrupting power lines, pipelines, satellite signals, and GPS systems. We've always known the ring current matters for space weather. What we've never had is a proper inside-out view of it.
Until STORIE.
STORIE. Storm Time O+ Ring Current Imaging Evolution, a joint NASA and U.S. Space Force mission that will be robotically mounted on the outside of the ISS after Tuesday's launch. Rather than looking at the ring current from a distance, STORIE sits within it and images outward, capturing one slice at a time.
Every 90 minutes as the station orbits, building up a complete picture of the full ring current.
Over its 6-month mission, it will track how the ring current grows and shrinks during solar storms versus quiet periods, and try to answer a question scientists have long debated. Where exactly do these trapped particles come from, the solar wind or from Earth itself?
The answer has real-world implications for how we predict and prepare for space weather events.
Keep an eye on the skies and the news on Tuesday night.
And our final wrap story for the week, another JWST milestone and genuinely a planetary science first.
Go on.
So up until now, when we've studied exoplanets with James Webb, we've been studying their atmospheres, the way starlight filters through a planet's air as it passes in front of its star. That's transmission spectroscopy, and it's transformed what we know about worlds beyond our solar system.
But this week, the telescope went a step further.
For the first time, JWST has directly analyzed the surface of an exoplanet. The target is a super-Earth just 48 light-years away, relatively close by cosmic standards, and what the telescope found is a dark, airless world, no atmosphere, geologically ancient. The researchers are describing it as a Mercury-like rock,
which is actually fascinating in its own right. A scorching, barren super-Earth with a surface you could, in theory, characterize directly.
The significance here is the technique. We've gone from studying what surrounds a planet to studying the planet itself, directly reading the surface chemistry from light alone.
That opens a completely new chapter in how we investigate rocky worlds. The next step, presumably, is applying this to planets' inhabitable zones, worlds where you might expect the surface to be far more interesting.
One more extraordinary week for the most extraordinary telescope ever built.
And that is your Astronomy Daily Weekend Wrap for Saturday, May 9th. The sun's hidden face finally mapped. A galaxy from the dawn of time that forgot how to spin. A planetary odd couple defying the rules. 200,000 volunteers who doubled the cosmic catalog. A mission launching Tuesday to study our planet's space weather donut. And Webb, once again, doing something nobody has ever done before.
Not a bad week for a universe that's just sitting there doing its thing.
On behalf of Avery and the whole Astronomy Daily team, thanks so much for spending part of your weekend with us. We'll be back Monday with the Daily Edition.
Until then, keep looking up.
And stay curious, everyone.